kind of about 30 minutes or 40 minutes, and then an opportunity to chat at the end. So Craig's going to press the record button in a second. I can't see if it's recording, but hopefully it will be. And
it's recording now.
Perfect. So what we're looking at really is tides and weather, and it's a huge subject, but we're going to scoot through it fairly quickly, just really of relevance to stand-up paddleboarding and sailing. So I thought I'd kind of start with a few things that made me think, how much do I know about tides in particular? We'll start with tides. What's more important, the moon or the sun? How do tides work? People talk about the rule of twelfths, and I don't know whether people know about the rule of twelfths, but it's a really helpful way of thinking about tides. And all these things have different names, don't they? Neap or spring tides. What's a neap tide? What's a spring? Where can you get the relevant information? And then as a result of tides, you get all sorts of funny effects on the water, tidal races, overfalls. And again, they've all got odd names. So something to think about. And finally, what happens to people who park on the beach at Weston-super-Mare? Well, the top slide says it all, really. If you park on the beach at Weston, Weston has one of the greatest tidal ranges in the country. It's in the Severn Estuary, and the shape of the estuary leads to a compounding of tide effects. And it's quite easy to park your car on the beach at low tide, and the sun's been on the sand all day or on the mud all day, so it appears quite dry. And you go out windsurfing, and then you come back and your car's underwater. So this is really where I learned most about tides early on. I used to windsurf at Weston quite a lot. And the thing about Weston-super-Mare is if you get the tides wrong and you go out to go windsurfing, you have to walk for about a mile through mud up to your knees to actually get out to the water. So tides became something that was kind of second nature to work out. When we think about tides, I always think about local places, and we're going to talk a little bit about Abu Dhabi, because that's a place that we go to with sailing and also with SUP. And again, it's a place with quite a big tidal range. So the two pictures here show low tide in Abu Dhabi and high tide in Abu Dhabi. And you can see there's a pretty big difference between what you get when you arrive there. Obviously, there are other effects, the weather as well. But if we just look at that tidal range and imagine that the shape of Abu Dhabi, there's a huge river estuary that goes inland, and we're looking up the river estuary here. It's an enormous amount of water, and the amount of water in that estuary, if you take all the water at high tide, must be many millions of tons of water. So it has an enormous effect on any kind of water activity. There are big currents, and as those of us who've been to Abu Dhabi know, in the middle of the tide you can get 4 knots of current very easily. So how do tides work? Hi there. We're just asking people who are connecting to mute for a second. We're just talking about tides and how they work. So in the best traditions of do-it-yourself, we've got a little model here of the Earth and the Moon rotating around each other. And the Earth and the Moon rotate around each other once every 28 days. It's the lunar cycle. And the effect of this, if we just consider the water on the Earth's surface, is twofold. The first is that there's a gravitational effect between the Moon here and the Earth, which pulls the water towards the Moon. And then there's a centrifugal effect. So as the Moon spins around the Earth, or the Earth spins around the Moon, both of them are spinning around a common axis, the water on the other side of the Earth gets pushed out, a bit like we get pushed out if we're on a roundabout. Now, clearly, during the day, the Earth is turning, and it turns once every 24 hours. So every 24 hours, the Earth goes round, and every 28 days, the two go round each other. So it's a really complicated system. But from a tide point of view, all we need to think about really is the relationship of the Earth and the Moon, and the fact that the Earth's spinning every 24 hours. And as a result of that, each point on the Earth's surface is going to be close to the Moon once every 24 hours. And the opposite point is going to be there every 24 hours. So there's a dynamic system, and it's not quite 24 hours because of this movement of the two around each other. It's 24 hours plus a bit because the Moon's going around the Earth. So every 28 days, you get an additional bit. So each day there's a movement in the tide times. Sounds a bit complicated, and it's further complicated by the sun. So what I'm going to do is just take us to the next slide. And we see here the Earth and the Moon and the sun all in a line together. Now, the Moon has a gravitational effect on the Earth, which is about 2.5 times the effect of the sun. So it's the Moon really that generates the tides, and the Earth turning gets tides generated by the Moon. So you can see in the next picture where the Moon's off to 90 degrees, it's still pulling most of the water across. But the sun has an effect, and it pulls the water as well. So if the sun and the Moon are lined up, basically you've got much more gravity working, and as a result you get much bigger tides. So we can see in this image there are really big tides because the sun and the Moon are in line, and if the Moon's off to the side, then the gravitational effect of the sun is countered by that of the Moon. So the tides are smaller, and the actual height of the tide is smaller. So we can see when we've got a new moon, which is the moon between the Earth and the sun. So when we look up in the sky, you can't see anything. You might have big tides. When we have a half moon showing with the Moon on either side, you'll have smaller tides, and a full moon, you get larger tides. So these kind of smaller tides are called neap tides, and the higher tides are called spring tides. And because the Moon goes round the Earth every 28 days, basically the interval between these is 7 days. So spring tide, 7 days to neap, 7 days to the next spring, 7 days to the neap, as that circulation continues. Why is it important? Well, let's have a look at Abu Dhabi. And actually this is this week, so it's very real data. And we can see on the left, on the 22nd of March, there was a neap tide. And the difference in the tides is very clear. You can see here the high tide, and it gives us a table, was 3.8, and the low tide was 2. So there's 1.8 meters of difference between high and low tide on the 22nd. If we compare that now with the 29th, there's a much bigger tidal range. We're closer to a full moon or a new moon. And because of that greater gravitational effect, we can see the low tide here is 0.5, high tide is 5.8, which gives us a much bigger tidal range, nearly 5 meters of tide. Why is it important? Well, it's important if you've got a boat, because you have to anchor the boat. You need to know how much room there is underneath it. But it's also important because of that huge volume of water that goes backwards and forwards. So again, just thinking about Abu Dhabi, here's the village of Abu Dhabi and the coastline. There's this enormous estuary that comes in and then goes right up towards Mahunlath and the Welsh mountains. And there's an enormous amount of water that's flowing backwards and forwards. In a neap tide, there's only a couple of meters difference. In a spring tide, there's 5 meters of difference. And that means really, if you think about the whole volume in that estuary, there's going to be a massive amount more water coming out on a spring tide and going back in than there is on a neap tide. So knowing whether it's a spring or a neap is going to make our planning quite different. Rule of twelfths helps us also just think about that movement of water. So we said that the difference between two high tides is about 12 hours. So high to low is about 6 hours. And basically there's a sort of sinusoidal shape to the way the water comes in and out with the tides. So around high tide, we have a period of slack water where there isn't very much movement. The tides come in, it's thinking about going out, it's starting to go out, and it's slack water. And there's a period of slack water also around low tide. So the tide's gone all the way out, it's thinking about coming back in, and there's a period of slack water. And for those hours around slack water, only about 1/12 of the tidal volume is going in and out. In the next hour, 2/12 of the tidal volume are going in and out. And then in the middle of the period between high and low tide, which is this area here, 3/12 of the volume is going in and out each hour. So in that 2-hour period between high tide and low tide, we've actually got the strongest currents, and about half of the water in that estuary is going past us. So if you're in a sailboat or on a sup, in that period between high water and low water, you can expect a tidal current around Abu Dhabi of around 3 or 4 knots. If you're at high water, you might have half a knot. If you're at low water, you might have half a knot. And obviously the water's coming out of the estuary at high and then back into the estuary at low. So the tide speed depends on where we are between the tides. This is a bit complicated, but if we have a look at it, these are actually the flows of water around the UK with tides. So here we are, the tide's running out. So it starts here at slack water, go out. This is the middle of the distance between the two tides, and it's roaring out very, and then it slows up, and then we're slack water again. It starts to come back. So we've got 2 periods of slack water, and then it builds up and it's come again here. So what we can see is that at slack, a lot of movement, but at the period between the tides, there's lots of movement. The tide is different at each place on the coast, because clearly it's caused by the moon going around the Earth, and the tide moves around the Earth's surface. So what you can find is tide times for each of these different places. And that's the information that you can look up, and we'll give you some sources a little bit later. But you can see it's really quite important to think about where we are in the tide when we think about the way the water flows. If we were thinking about the Bristol estuary, we talked about the Severn estuary and Weston-super-Mare, which is up here. You can see the water flowing out at high speed here, and then it turns and it's flowing in at high speed here. So there's a kind of terrific change in the movement over a very short period of time. And you can really see that the length of arrows gives an indication of how strong that tidal flow is. These tide charts and flows you can get, and this is obviously a general one showing the whole of the Welsh coast and Irish coast, but you can get very specific ones that zone into the area that you're interested in. So if you're going sailing and you want to sail around kind of the Lynn Peninsula, you can get very accurate flow charts for the Lynn Peninsula, which show the tidal flows. And they points on the coast. On a neap tide, you might get a much lower flow, but the flow is going to be in the same direction relevant to high tide and low tide. So obviously the tide and the flow going around the land gets compressed in places. So the top image is a headland, and you get a tidal flow going around that headland. And as it gets pushed around the headland, it speeds up. So it's quite slow here and it gets speeded up around the headland and then it slows down again. And if that headland's also associated with a bit that sticks out underneath, actually that speeded up tide running over a shallow bed gives you really disturbed water just down tide or down flow of the obstacle. And this is what's described as an overfall. And overfalls get marked on tide maps. So when you see a tide flow, quite often it'll mention an overfall. And this is really uncomfortable in a sailboat, and it's practically impossible in a sup. So if you were going round a headland in a sup, you wouldn't want to go round at the peak of the tidal movement between tides. You might choose to go round at the slack water, either at or at high tide. And clearly you want to use the tidal flow to assist you going round. The other area where we get compression is obviously between islands, and this is really significant. There's a very famous area in Scotland called the Gulf of Corryvreckan, where actually, because of the configuration of the islands, you get high tide on one side and low tide on the other almost simultaneously. And you get a tide racing through here at 8 knots. It's going so fast you can't sail a sailboat against it. And it's going so fast that it creates whirlpools. So knowing the local area is really, really important. And if you get really complex areas, like lots of little islands and the big gulfs around, there's the Argyll coast and the Clyde estuary, you get really complicated patterns. Luckily for us at Abu Dhabi, there's just one estuary with the tide going in and out, and it's not too complicated. And that's true of most of the Welsh coast. When you go around with sort of the end of the Lynn and Bardsey Island, and as Maria will know, going around Anglesey, you get really vicious tides and really strong tidal flows. So where you are is quite important. So just thinking about tides for Abu Dhabi, what are we looking to do? If you want to go to Abu Dhabi and have an hour's paddle and pootle around, then it kind of makes sense to go at low tide or high tide, where you know you're not going to be pushed too far away from where you've launched, and the tide isn't going to be running too quickly. So if we were planning a trip to Abu Dhabi and we wanted to go for an hour, then launching at low tide or high tide would make sense. If you launched in the middle between the two, you've got 3 knots of current, and your choice is either to battle against it and stay in the same place, paddling like crazy, and then turn around and come in, or to go with it and find yourself halfway down the estuary towards Mahunleth and then a really hard job getting back again, or worse, maybe getting carried out to sea and a really hard job getting back again. However, if we want to go for a really good trip at Abu Dhabi, you might choose to go at low tide, launch at Abu Dhabi, and then use the tide to push you all the way up the estuary. And then you can get right up to the bridge at Mahunleth, you can get out, have a picnic, wait for the tide to turn, and then go back on it all the way back to Abu Dhabi. It's a big trip though. It's 12 hours between the tides, but you can leave it for an hour. You're still on slack water, or maybe even a couple of hours. And then the water will get faster and faster and then slow up and then turn and start to go back again. But clearly you have to be a bit mindful if you're going back out on a high tide that's running back out to sea. It is going to be running back out to sea, so you have to make sure you're ready to scoot into the beach at Abu Dhabi and not sitting right out in the middle of the estuary where you'll get funneled out to sea. And then we talked about neap tides or spring tides. If you want to go for a relaxing paddle at Abu Dhabi, the time to go is on a neap tide. So there's less tidal range and less current. It allows you to be much more flexible about your timings and when you go, and it gives you a lot more discretion really about coming in and out. And the easy way of remembering it is you get a neap tide when you can see a half moon. And most diaries actually have a half moon marked in them, or a full moon, or a new moon. So it's pretty easy to look it up in your diary. The high tide doesn't exactly follow the moon. It's just a few hours behind. So you need to look up tide tables to be super accurate, but it's good enough for an approximation. So if you're planning to go to Abu Dhabi and you want a gentle experience, look for a neap tide. Go when you can see a half moon. And there's one final thing about tides, which we ought to just be careful about. And that's really when you get the tide moving in one direction and the wind moving in the opposite. And if you get the tide coming one way and the wind going in the opposite way, what it does is it causes a lot of turbulence over the surface. And you get really nasty, choppy waves, which make life very uncomfortable. So wind over tide is a bad ride. And you just need to think about that if it's a windy day. So there we are. That's tides in a nutshell. There's kind of quite a lot to get your head round. But the key thing is really, usually there are 2 tides in a day. There are some disclaimers. All the green areas here have 2 tides, but because of the real complexity of the Earth's surface, some of the areas just have single tides. But we don't really need to worry about that because they're not areas close to home. But just occasionally, when you go off somewhere different, like Australia, things don't work out quite as you would expect. So knowing whether you have a diurnal tide is quite important. For most of Europe and most of the eastern states, it's all diurnal, and that's 2 tides in a day. Knowing when high tide and low tide are due is important. Knowing about neap and spring tides, and knowing about the 12th rule. So that's tides in a nutshell. And we just need to check the tide tables before going on the water and just be aware of all those kind of funny tidal races and strange effects. And local knowledge is really, really important. So if you're not sure, just talk to people who sup or sail in those areas regularly. So that's tides. We'll just think briefly about weather, and it's really whether or not. There are lots of things in weather, and again, if we're planning a trip, maybe just a day trip, maybe we just want to go for a poodle, probably the things we need to think about most with SUPs are the effects of wind. We all know that battling wind is hard work on a SUP, and the wind not only makes it hard work, but if you've got a lot of water, it actually affects the sea state and creates waves. So wind's important, and whether it's onshore or offshore, we'll come on to that in a moment. Clearly, we need to think about visibility. There's bad news if you go off and you can't see where you're going. And temperature. And temperature is affected not only by the air temperature, we need to think about the water temperature, but also wind chill. If it's a windy day, it's going to be much colder or feel much colder. If it's overcast, you get cold pretty quickly. And if it's raining, you get cold very, very quickly because your wetsuit's soaking. Changeability of weather is also important, and there are lots of local effects. So we'll talk a little bit about those. But it's just being mindful of all these various things if we're planning. So a few top tips. High pressure, an anticyclone, tends to be very stable. And we all know that, it's typical summer weather. A big anticyclone gets sat over the UK. We get very stable weather. It doesn't change very much. Which way does the wind go? If you draw an H and then follow round, that's the way the wind goes. So H, and the wind follows in that direction. So the wind basically goes clockwise round an anticyclone. And a low pressure, a cyclone, it goes the opposite way. And again, if we draw an L, the wind will go this way around it. So that just helps us make some sense of pressure charts, and you can kind of see straight away which way the wind is. So on this one, we know there's a southerly wind going up the Belgian coast. We know there's a northerly wind coming down this way. And if that anticyclone starts to move across into continental Europe, we know that we're going to start getting northerly winds. But basically, wind flows from high pressure to low pressure. So it's trying to go from this high to that low. But because of something called the Coriolis effect, as it's trying to get there, it gets spun round by the Earth's rotation, and you get rotation. So high pressure, it goes round clockwise, low pressure goes round anti-clockwise. And we mentioned Australia earlier. The Coriolis effect goes into reverse in the southern hemisphere. So you get really caught out when you go sailing in Australia because the wind goes the opposite way around these features. So wind is always trying to go from high pressure to low pressure. And depending on the pressure difference, you get different speeds of wind. So in that anticyclone, going back again, you can see there's not a lot of pressure difference here. The isobars, the lines of equal pressure, are really widely spaced. So there's not a lot of pressure gradient. So there's not a lot of wind. In contrast to the low pressure, where you can see the isobars are getting crushed together quite tightly. And as a result of that tightness, there's much more wind. So wind strength's measured in lots of different ways, Beaufort scale, knots, kilometers per hour. But from our point of view, it's the effect of the wind really on us and on the sea state. So in supping, we're looking for winds in the lower range, 3, maybe 4 as a maximum, unless you really know what you're doing or you've got an area where you're very confident that you've got good shelter. So we know at Chelmarsh there's great shelter under the trees, and we can go supping because we know it's a protected lake with really quite strong winds. And I think we've probably all been out occasionally in winds of 20 knots, gusts of 20 knots certainly. Branches shaking, little waves, a little bit of spray occasionally. I can remember a Supfest where it was a bit more dramatic than that. That's fine at Chelmarsh, but if you're in the Abu Dhabi estuary, we have to remember the effect on the sea. And I'll show you a picture in a minute which shows that very nicely. But basically, the bigger area of water, the bigger the waves are going to get. And the stronger the wind, the bigger the waves are going to get. And it's going to become very unmanageable very quickly unless you've got a short board and you're very experienced. So wind strengths and the Beaufort scale, but I think we all get used to just having a look at it. And I think one of the best lessons is really just to look at the wind every day and see how windy it is and just learn what that means in knots or miles an hour and have a look at weather apps and just do that. I spent probably 15 years of my life, first thing I do every morning was look out of the window and see what the weather was doing, because I had a job that relied entirely on the weather. And it's just fascinating, and it's really good to develop that as a habit. So back to Abu Dhabi. We want to go supping. We've chosen high water in this instance, and there's not a breath of wind. So you can imagine you'd have a very easy and delightful day trying to paddle at Abu Dhabi. Contrast with the picture below. The first thing we notice is the wind. You can see it's windy because the kite surfers are moving pretty quickly and the windsurfer's got good speed on and a lot of spray behind it. And the next thing we notice is the direction of wind, because you can see that the kite surfer is kites out towards the sea, the windsurfer's sail is on the seaward side of the board. And so actually the wind's blowing out towards the sea in this picture. So what we've got is an offshore breeze. It's blowing offshore. So if you go out supping and your sup's in the middle of this, you're going to get blown offshore pretty quickly. And offshore means getting blown out through the mouth of the estuary and out into the open sea fairly quickly. The other thing that we notice is the effect on the water. So even though it's low water here, you can see there's quite a lot of wave, even though we haven't got much distance on the water. So it's a windy day, it's an offshore breeze, and it would make it pretty uncomfortable for going sopping, because you'd be fighting against that wind. Even if this is low tide and the tide's starting to come in and the tide's pushing you in, we'd have that classic wind over tide situation where the tide's coming this way, the wind's going in the opposite direction, and very quickly you'd get great big six foot waves, even in the sheltered estuary at Abu Dhabi. Visibility, again, knowing what the visibility is really important. And again, in a high pressure weather system, you might have really poor visibility. You tend to get early morning fogs. You can quite often get quite dense sea fogs. Again, mostly they're predictable, but knowing about it is important. You can drive to Abu Dhabi and it can be beautiful and you think this is going to be a cracking day. It's bright and sunny, and as you get to Abu Dhabi, there's a wall of sea fog and you see it as you start going down the estuary, and it takes ages for it to clear. The other visibility risk is obviously rain. If it's really bucketing down, you can be in trouble with rain. So we talked about changeability and that high pressure system being very stable and it not changing very quickly. Low pressure systems change really quickly. And we all see the weather maps with these low pressures coming in across the Atlantic and hurtling across the UK. So again, if we're planning a trip, in the few days before the trip, you can see that you've either got a nice, great anti-cyclone, very stable weather, it's not very changeable, or you get the opposite, where you get lots of low pressure systems rattling in with tight isobars, windy weather, and these things which are fronts, and here's a cross section of a front. So on the front of the low pressure system, you have a warm front, and on the back of it, a cold front. The warm front you can see coming because the sky starts to get high cloud cirrus, and it gradually gets lower as altostratus, and then eventually you get this really low mat of nimbostratus, and then usually rain. And then the front goes through and you get a clear interlude in the middle, and it's actually quite pleasant. It's warm air, but the trouble about warm air is warm air wants to rise. So the warm sector is met then by a cold mass of air coming in behind, and the warm air that wants to rise rises really quickly, and it develops very quickly into these big towering clouds, cumulus clouds. So on that cold front, very often you see quite big cumulus clouds at the start of it, and very quickly, and you can see it's motoring along at high speed, and it's quite a vertical front, you get these really big towering cumulonimbus clouds, which are hugely dangerous from an aviation point of view because there's a huge uprush of air in them, but that uprush of air also causes huge circles of air spinning around the clouds. So you get really big, gusty, stormy conditions with sudden and vicious wind gusts. You might have hailstorms. And it's the sort of pattern that you see frequently when you get those really nasty, big thunderclouds. So you see a thundercloud on the horizon, you're in this sector, it's really clear, and everybody at the sailing club says, be careful, if that comes any closer, we're going to have lightning, we could have really strong winds, it could get changeable very quickly. Fine at a sailing club, because we can get everybody off the water very quickly. If you're at Abu Dhabi and you've decided to go sort of 2 or 3 hours down the estuary, you're not going to get off very quickly. So again, changeability and just being very mindful of how quickly the weather might change and trying to choose good, stable conditions. The other thing we need to think about more on the coast than at Chelmarsh is sea breezes. And again, the sea breeze is something caused by heating of the land. We've all been at the seaside on the beach. It's a nice calm day. And then during the afternoon, you get a cold wind that starts to come in off the sea because the land is warming up and the air is rising. And as that air rises, the pressure is dropping here. And so pressure from the high pressure out over the water is filling in quickly and you're developing a sea breeze. So a sea breeze is an onshore breeze. it's actually strongest when you have an offshore main breeze. So if you have what we call a gradient wind, an upper wind that's blowing offshore, that gives you the perfect conditions then to generate a really strong sea breeze. And you can see it coming. You can stand on the beach and you can see calm water and then ripples, and you can see it coming towards you, and it fills in. The sailors always like it because it's a brilliant wind to sail on, because it's onshore, it's nice and safe, it's blowing you back towards safety, but it gives you great sailing conditions. It's good for SUPs as well, because again, it's onshore and it's bringing us where we want to go. A land breeze is the opposite, and that you might get this in the evening. I'll show you some evening pictures in a minute, but if you go supping in the evening, you may start to get the land cooling towards sunset, and that sea breeze reverses and it becomes a land breeze. And again, the air drifts out, and then as it goes out, it starts to rise and you get cumulus clouds developing offshore. So if we know about sea breezes, they're predictable, but not very predictable. But often if it's a good hot day, you're going to get a good going sea breeze. In equatorial regions, if you go off somewhere really hot, or maybe you go to Greece on holiday, you may not get huge sea breezes because the water's pretty warm, the land's pretty warm, and it's all mixed up, and you don't get the strong sea breezes. That's true in a lot of places, but then you can go to Vasiliki in Greece and you get massive sea breezes because there's a big mountain there. And that's where we get what we call an anabatic wind. So if you've got warm land and the sun's shining on it, you can actually get an awful lot of wind generated by heat rising up that mountain. So it's called an anabatic wind, where you get a lot of wind rushing up a mountain. And then finally, thermals. Thermals are caused by the sun heating the land, and you get little bubbles of hot air forming on the land, and then they break away and go up, and they'll generate a thermal breeze around them. Thermal breezes tend to be quite light, and they're quite pleasant, and shouldn't worry us too much. But if thermals get very big, and you've all seen pictures of the sort of Serengeti parks in Africa, you can get enormous thermals, and again, those big cumulonimbus thunderclouds forming. And the Attenborough films, you often see these kind of wonderful, big building cumulonimbus clouds. So wind changes, and it's changed by the topography. And this was just a lovely picture because it shows about a million things in one picture. The first thing that I notice about this picture is it's relatively stable air. There are no big frothy cumulus clouds. It's a nice laminar, stable looking cloud, stratus cloud. Maybe this is an alto stratus, quite high cloud. But it gives me the feeling that it's quite a stable air mass. It's quite windy. You can see the wind patterns on the water, and the wind is blowing towards us from the top towards us. And we can tell that because we can see the waves, and you can see the front face of the wave. So you can tell which way the wind's blowing just by looking at the waves. And then the next thing that I notice is the wind's bending. So you can see here that it's coming down the shape of the land. And then at this point, it's turning around and going around the corner. So the land here is creating a change in the wind direction. We all know from supping on rivers, whichever way up you go down a river, you always have a headwind. And that's often because actually the wind's going across the river, but it hits the other side and then it blows towards you. But so the wind direction here is actually altered by the land. And the other thing that we can see is something called the fetch. Because there's an awful length of water here, very big length of water, right the way down this long lake, actually the waves get quite big. So even though this is a lake, you can see these really big waves. And that's because the wind is going along the line of the lake, and it's got a long fetch, a long distance across the water, which allows it to create big waves. If the wind was going the opposite way, or 90 degrees across this feature, the waves would be much, much smaller, because the wave height is actually determined by how long the wind goes across the water. And that's relevant. If you go to the Atlantic coast, you've got the whole of the Atlantic upwind of you with a westerly wind. If you're in Wales, you've got less because you've got Ireland in the way, but you've still got the whole length of the Irish Sea. If you go down the Abu Dhabi estuary, you've actually got much less because you're in a protected piece of water and there's a neck at the end and the sandbanks at both. So there's much less space for the wind to go over that water and create big waves. So there's a few things to think about from a weather point of view. The information that we use for weather is wide. So there's the Met Office, the BBC, Wind Guru, Big Salty, Magic Seaweed, everybody's got their favourites, but there are lots of different sources of weather information. Tide information may be less familiar, but there are some really good apps that you can get, My Tide Times, Tides and Tides Near Me. And there's a fantastic shortcut for anybody who wants to go to places on the Welsh coast. There's a tidesforfishing.com website, which actually includes not only tides, but also weather, and it gives tidal flows as well. And the final thing it gives you is how many fish there are on the bottom of the river or the sea. But it's a really good shortcut for having a look at things. The other link that I really like is What Three Words, because we know if you're going off somewhere that's unfamiliar, knowing where you are is really important, and you're going to have a phone with you. And as we all know, the RNLI really like What Three Words, and it's a fantastic geolocator. So some final pictures. Last year we went off in September and it was actually quite a windy week, and we weren't sure whether we were going to be able to go supping. But the first day was before the wind developed. So this was Cricketh on the first day. We went out just before high tide. The tide was coming down the coast. So we went against the tide, paddling against it, basically traveling west from Cricketh, and then turned around and came back again. But it was a nice, gentle journey, and we could see the tide because there were sort of fishing floats in the water and you could see the water passing by. But by choosing a calm day, by choosing an hour either side of high tide, we had the perfect time really to go out on the water. This was a bit later in the week and actually is Aberdaron, and you can see it's quite unsettled weather. There's some puffy cumulus-like cloud. This is the end of a front that had gone past through the day. It had been quite windy, but we were able to find some shelter from the cliffs along the side up behind us. And even though it was an offshore breeze, we were able to go supping, but we had to be careful. You can see there's a bit of breeze on the water. We had to be careful not to go too far out, because the further out you go, you can see here, the grayer the water gets. In fact, there's more wind out here. So close in, there wasn't too much wind because we were protected by the cliffs, but further out, there was more wind and it was blowing offshore, and we'd have ended up on Bardsey Island very quickly. So just a few thoughts really about planning, about tides, and about the weather for a trip. And I thought it was just a short introduction just to get us thinking before we plan our adventures over the summer. So that's kind of where we are. I think Craig was having a look at any questions. Let me just see if we've got anybody who's got any questions, Craig.
There's nothing on the chat bar, but anyone
Perfect.
wants to take the mics off and ask any questions.
Should we turn the recording off and then have a chat?